Welcome to X-ray diffraction virtual training. This is the second part of instrument control. As a review, we have already covered how to warm the X-rays up and how to do an optics alignment. That optics alignment was part of the general program that you had selected. You should have also watched a video tour of the instrument and a video on how to change out the stage components. So next up is sample alignment, and in this portion of the training, we're also going to cover general measurements as well. So within sample alignment, when you press that button, you're going to get a window that looks something like this. This is for a Bragg-Brentano experiment. We'll also cover what this window looks like for a parallel beam experiment. So within this window, you have three choices at the top. The first one is no height alignment. I don't recommend that you do that one. The second is if you have a curved sample. And what I mean here is something with lots of curvature, like a rock. The final choice is a flat sample. And when we say flat, we're really meaning like flat on the order of hundreds of microns. So it does not have to be atomically flat to choose this option. If you do choose a flat sample, you need to enter a sample thickness. And that sample thickness is going to depend a little bit on the type of sample that you are looking at. So, for example, if you are looking at a thin film on a substrate, then your thickness, you're going to want to use a thickness that includes your substrate thickness. But if you have a powder that you have packed, for example, in the glass well plate, your thickness is going to be 0. That well plate is going to fit into a holder that allows it to, it's a spring-loaded holder that pushes the top of the sample against a solid support. And so the sample is always at exactly the same thickness. And in that case, your sample thickness is 0. If you have questions about this, please feel free to ask me when we do your in-person training or your live training. So once you've chosen these two and you press execute, it's going to do 2 scans. The first scan is a Z-scan. And in this scan, the sample starts well below the X-ray beam. So the X-ray beam starts at the source, goes to the detector, and there's nothing in its way. But now we're going to slowly move the sample up until at some point it blocks the X-ray beam and we get no signal at the detector. By using this data, the software can determine the optimum height for your sample when you do your measurements. So that is the first alignment that it does, is this Z-scan. Now if you say that you have a flat sample, it's also going to do an omega scan. So let's talk about what this is, and then I'll show you on the diagram how it executes it. If you have a flat sample, it is possible that that sample is flat but not perfectly horizontal. So one example of this is, let's say that you taped your sample onto something, and maybe you pressed on the tape a little bit more on one side than the other. The sample's still flat, but maybe it's tilted just a little bit. And so what we want to do with this alignment is essentially align the instrument 0 to the tilted sample so that the instrument is essentially aligned to the flatness of your sample. The way that this particular omega scan works is that the source moves down while the detector moves up, and then it switches. So then the source would move up while the detector moves down. And what it's doing is it's trying to find the maximum signal intensity. And that is where it is aligned with your sample. So once you've chosen one of these, you're going to press execute, and it's going to come up with a window to help guide you through the experiment. Before we do that, though, let's take a quick look at what this looks like in parallel beam mode, because it's a little bit different. So in parallel beam mode, we have 3 things that we need to enter. The sample thickness is just like we talked about before, and these are all defined at the bottom here with respect to the X-ray beam, which is shown in red. The sample height is the length of your sample perpendicular to the X-ray beam, and the width is then parallel to that X-ray beam. Now this is important because if your sample height is small, for example, the software may tell you to put in a slit that will limit the beam in this direction. So for example, you don't want to have a very small sample and then have the beam irradiate a very large area. You may collect data from spots other than your sample in that case. So once you fill in these top 3 parameters, I usually leave the rest of these parameters just as they are set and go ahead and press execute. Now, once you do press execute, you will get another smart message. Now, the point of this is to guide you through the experiment, to tell you exactly what you need to do. You may have instructions that look a little different from this. The point is that you just need to follow those instructions, and the software will guide you through what you need to do that sample alignment.